Let me derive the formula for kinetic energy and show you how to calculate that. Um, so with kinetic energy, with potential energy, we lifted something and gave it energy by lifting it from down here to up here. With potential energy, what we're going to do is we're going to push something along maybe a frictionless surface here with some force F, right? And we're going to do that, we're going to push it some distance s from here to here. And let's assume that its initial velocity is 0. Well, then all the energy it's got when it's going v comes from the work we did, right? So work is F times S, right? And then what I'm going to do is I'm going to substitute, since this thing is accelerating, right? I'm going to use F equals ma, and I'm going to substitute ma in there for the force, right? So we get m times a, okay? And I would make a joke about that, but you guys would probably say, no mas, right? Okay. But here's a problem is that we don't have the v in there, right? Okay. And so I'll bet that it only depends on that final velocity. So what I'm going to do here is just mess around here. I know that v squared is u squared plus 2as, right? And if the initial velocity is 0, right, then we can solve this. I guess we can say that s is equal to v squared over 2a, right? And I can substitute that in there, right? So I get ma times v squared over 2a, right? And then of course the acceleration cancels, which is serendipitous as well, right? So it doesn't matter how it gets to that speed, right? We could accelerate it with a huge acceleration over a small distance or a small acceleration over a large distance. It's only the final velocity that matters, and that makes sense, right? So we have mv squared over 2. Most people write it this way. Kinetic energy is 1/2 mv squared. In fact, the book is going to write it this way. The rest of the world, this is the IB way of writing it. We just say Ke is 1/2 mv squared, okay? Where v is the velocity in meters per second, mass in kilograms, right? This will be kinetic energy in joules, okay? So if I've got a baseball going 40 meters per second, right? That's about 90 miles per hour. Its kinetic energy is, well, baseballs have a mass of about 0.145 kilograms, right? And then if they're going 90 miles per hour, which is about 40 meters per second, right, you square that. And then since you square the velocity, it goes up really fast with the velocity. If you double something's velocity, you actually quadruple its kinetic energy, which is, you learned about that in driver's ed, right? Or will learn that, speed kills, right? Okay, so times 40 squared. This is 116 joules of energy, and that's, that would hurt, right? That's why you got to wear a helmet when somebody's throwing a ball like that at you, okay? And here's, the question is, how do we get joules? Well, obviously it's going to be kilograms, and then it's going to be meters squared over seconds squared. Well, a kilogram meters squared over seconds squared, if you recall, that is a joule, right? It is the same as a kilogram meter over second squared. That's a Newton, right? Times a meter, right? Okay. And that's really all you need to know. The important thing about kinetic energy is that it's quadratic, right? It's v squared. So if we do a graph of energy versus velocity, it's going to shoot up like a parabola like that. Okay. And that's all. I'll do some examples, but I'll do them in a different video.